Hi, my name's Matthew Smiles, and welcome to my talk at Stemfestinspace called Solar Panels in Space. Now, I'm really honoured that I got a chance to do this talk today. I really hope that you can learn something interesting and exciting from it. It's certainly a topic that I find to be interesting and exciting. So, the reason that I find it to be so exciting is my job is to research materials that might be used in solar panels in the future. And what I'm going to tell you today is how, without the space industry, I wouldn't have my job today. So, I'm going to start by talking about solar and the space race. Then, I'm going to go on and give you a few examples of how solar panels are used in space. Next, I'm going to tell you how, without the space industry, we wouldn't have the solar industry. And finally, I'm going to teach you how it works and what we're going to do next to try and make our solar panels even better than they are today. So part one, solar and the space race. So the story of solar starts way back in 1876 with this man, William Adam. Now he made the first ever solar cell. A solar cell is like a tiny little thing that you can fit in the palm of your hand, as you can see in that picture. And if you connect a lot of them together, you then get a solar panel. Now, this was done for the first time just 8 years later by someone called Charles Fritz. Now, he put this on a building in New York City, and he managed to get a nice steady flow of electricity out. Now, it then took 70 years later for someone to actually be able to sell these solar panels. So that was happening by a group in the US called Bell Laboratories. They made the Bell solar battery. And on the left there, you can see a radio being powered by a solar panel. On the right, you've got a little Ferris wheel that would turn when the light was shining on the solar panel. And then when the light was turned off, the Ferris wheel would stop turning. So it was a really cool bit of technology, and you had someone willing to sell it. The problem was, it was really expensive. So it's going to cost $1.45 million to power a US home with these solar panels. So there was a manufacturer willing to make them, a technology that worked, but nobody wanted to buy it until Dr. Hans Ziegler came along. Now, he was working on a super secret project for the United States called the Project Vanguard. And what this secret project was they wanted to become the first country in the world to get a satellite up into space. And what I mean by a satellite, it's a man-made object that orbits around the Earth. Now, he realized that solar power would be the perfect way to power these satellites for a few reasons. So first, it's a lot less constrained up in space. So whereas solar panels down here on Earth do have limitations based on the weather and nighttime, up in space you've got a lot less of those being an issue. Secondly, there's the weight versus power argument, where whenever you think about space travel, you always want to minimize weight for a few reasons. So firstly, the more heavy something is, the harder it is to get into orbit. And secondly, the more heavy something is, the more costly it is to get it into orbit. But if you send a satellite up in space, you want to make sure that you've got enough power to power all the electronics that's on the satellite. Now, the advantage of solar is you can choose how many solar panels you need depending on the electronics you've got on board. So say, for example, if you had a satellite with very little electronics on, then you could have a satellite with very few solar panels. And similarly, if you have a lot of electronics, you can have a lot of solar panels. Now, a third advantage was there's unlimited fuel. So while the sun's shining, these solar panels have fuel. Now, if the sun ever did stop shining, then technically they'd run out of fuel, but we'd have much bigger problems than our satellites not having enough electricity. So, and the final advantage was the alternatives were very limited. So the main alternative was a battery, and a battery, once it runs out of power, that's it. So a battery could only last for a few days, weeks, maybe months. Whereas solar power, there was no telling how long it could last for. So this is it. This is the Vanguard 1 that was launched on St. Patrick's Day in 1958. It was tiny. It was only a 16-centimeter wide ball, so half a ruler wide ball, with a few solar panels dotted around the surface, as you can see. And it's actually still the oldest man-made object orbiting around the Earth, but it didn't succeed in being the first satellite in space. The first was the Sputnik 1, which was put up by the Soviet Union, or modern-day Russia. That was launched the 4th of October the year before. And that was a battery-powered satellite that lasted 21 days. Now then, the Russians again got the second satellite into space. That was just a month later. And this satellite's really famous for having the first ever animal in orbit. That's Laika the dog, very cute dog. But this battery-powered satellite lasted only 6 days. Then the United States got a different satellite, a battery-powered satellite, up into space before the Vanguard 1, called Explorer 1. That launched the 31st of January the year after, and that lasted for 4 months, which was a significant improvement on the first two. But then the Vanguard 1, the solar-powered battery, launched 17th of March that year. That lasted for 6 years, so it's gone from days and months to years-long power. Now, the contribution of Vanguard 1 to our understanding of space and our understanding of how these satellites could work in space was so much more significant than the first three. And we also learned that the only way that satellites can really be powered is through solar, because if you're going to spend millions of dollars to put satellites up into orbit, you want them to last years, you don't want them to last days and weeks and months. Now, this space race was a sort of a good side to a bad international conflict. The space race was the two major powers at the time, the USA and the Soviet Union, wanting to show they were the most technologically advanced countries in the world. The USA managed to get the first person on the moon, but the Soviets got the first satellite into space, for example. Now, these two countries were both nuclear powers, and what I mean by that is they both had nuclear bombs, and there was always this threat that there was going to be a nuclear war. Now, when satellites first came into space, they initially could start taking pictures of what was going on down on the surface. So it meant the United States could learn a lot more about what was going on in the Soviet Union. And likewise, the Soviet Union could learn a lot more about what was going on in the United States. That took away a lot of secrecy involved in the conflict between the two. And then on the left there, you've got the Vela satellites. Now, these were solar-powered satellites, and these could detect, and still can detect, if there's been any nuclear testing going on. So that led to a first treaty between the two countries where they agreed to limit nuclear testing. And on the right there, you've got a missile. Now, these missiles, very cleverly, can be guided by solar-powered satellites. And this meant that, say, if the Soviet Union decided to nuke the United States, they now know that they've got to be able to hit these missiles straight away, or the United States is going to be able to nuke them back straight away. So this sort of created a little standoff between the two, which has led to a number of treaties being signed and a number of agreements being made that's really reduced the risk of nuclear war between the two countries. So what I'm basically saying is, without the solar-powered satellites, without solar panels, we wouldn't have the nuclear peace that we have today. So part two, other than creating nuclear peace in the world, what other applications have solar had in space. So a first example is the Global Positioning System, or GPS for short. Now, some clever scientists last century figured out that if you had just 24 satellites going in different orbits around the Earth, you would be able to detect a GPS detector anywhere on the surface of the planet. So anyone that's used maps on the phone, used Pokemon Go, used Instagram filters with location filters on, used Snap Maps, any of these things have all used GPS. So GPS has really improved sort of small things in our lives, but also really improved navigation around the globe. All of this solar powered. Satellite TV. So satellite TV, if anyone's got a satellite dish on the roof of their house to power, say, a Virgin Media box or a Sky box, then they've used two satellites all powered by solar to be able to receive the channels. And these satellite TVs have meant that we can get a lot bigger range of TV channels compared to if you just go on your Freeview where you can only get a limited number of channels. Third, weather forecasts. Now, weather forecasts have improved in two ways because of satellites, solar powered satellites. Firstly, you can image the area. So say on the left there, you can image the UK a lot better from up in space compared to trying to do it with, say, a plane. And secondly, you can then have satellites that can pick up data like precipitation levels, winds on the ocean, these sorts of things that then forecasters can then use to put into their models to try and predict what the weather forecast will be. Now, solar's really improved it. I don't think solar panels can be blamed for how bad the weather forecast sometimes is. Another example, the International Space Station. So for those who don't know, the International Space Station is an international effort between lots and lots of different countries to have a space station that orbits around the Earth. Now, this space station has taught us a lot about how humans can survive in space and how equipment can survive in space. That's going to be vital for when we try and get people back on the moon and then go even further and get people on Mars. Now, as you can see, these there's 4 wings of solar panels that power everything on board the International Space Station. So all the electronics that keep the astronauts alive, all the electronics that power the science equipment, that is all powered by solar. Now, to do this, the wingspan of those, each of those has a wingspan of 73 meters, which is wider than a large aeroplane. There's a 2,500 meters squared of solar panels. That's a bigger area than about a third of the pitch of Wembley. 240 kilowatt hours of power, which is enough to power about 40 homes, and 8 miles of wiring to connect it all together. It's a really huge effort up there. And then you've got space telescopes. So this example is the Hubble telescope, possibly the most famous telescope, space telescope, but there are others up there. And the advantages that space telescopes have over ground-based telescopes is similar to what solar panels in space versus on the land is. So you don't have as much of interference from the atmosphere when you've got a satellite space telescope, and therefore you can get much better readings. So this Hubble telescope has allowed us to produce some absolutely wonderful images. So I've got a few here, and some of the stuff it's managed to teach us is we found moons on the outside of Pluto. We've found black holes that we didn't know existed. It's allowed us to understand how planets and galaxies form. It's allowed us to understand how supernova work. So the death of stars much bigger than our own sun. It's even managed to help us date the universe. Now, all of the electronics on board these space telescopes are all natural, solar powered. So it's allowed us to understand our universe so much better. So moving on to part three. So whereas in the last two parts, I've talked a lot about how solar power was the natural solution for a lot of applications for space industry. Now I'd like to talk about how without the space industry, solar industry wouldn't exist today. So if you remember, I said it was going to cost $1.45 million to power a US home with solar panels way back in 1958 when they were first starting to get commercialized and start getting sold to the public. So no one was going to buy them. So you had these companies willing to make them and nobody wanted to buy them until solar came along. And solar then pumped a lot of time and a lot of money into improving the efficiencies, bringing down the costs. And they did that because solar panels had solved a problem that they had in space. And so that's what space does when they have a problem. They put a lot of time and money into trying to solve it. And that meant that the cost came down low enough that companies down here on Earth started to take note and start to think, well, hang on a minute, maybe these will be good for us. So it started on oil rigs. They tend to be quite isolated, can't connect to the national grid. And so they have to get diesel generators and batteries to power some of their electronics. And then they figured, well, if we put solar panels, then that means rather than send someone out every 2 or 3 weeks to replace the diesel or put in a new battery, then they could just put the solar panels and leave them and save themselves a lot of time and a lot of money. And then similarly, foghorns and lighthouses, they realized that they had the same problems and solar was the obvious solution for them. And then rural areas, so I'm not sure where this picture's taken, but the Australian outback's one example where a lot of their rural communities aren't connected to the national grid. And so rather than rely on these diesel generators and these batteries, they could start to rely on solar power for their needs. But how has it gone from a few isolated little applications of solar down in space to the way that it is today, where a lot of you, when you go home from school today, you'll pass a house that has a solar panels on its roof? And that sort of happened for three reasons. So first, the United States in the 1980s had the incident called the oil embargo. That meant a few of the countries in the Middle East that exports a lot of the world's oil refused to sell oil to the United States. And that caused a lot of issues for the states. And they realized that it's a lot better to not be dependent on other countries for your energy, for your electricity. Now, solar was one possible solution for them because it meant rather than having to rely on bringing oil, once you've got your solar panels up and running, they can provide you energy for 25, 30 years. Secondly, people started to realize that coal, oil, and natural gas, which are the fossil fuels, the main three ways that we make electricity, or made electricity anyway, we realized that there was a limited amount of them. So at some point, we're going to run out of all three. And the question was, well, what are we going to do then? We can't just not have electricity. So then people have started pushing for renewable types of electricity, like solar and wind, that aren't going to run out. And so that was another push towards solar. And then finally, climate change. Now, this is a talk about space, so I don't want to get too into the science of climate change, but because of the greenhouse gases emitted when we burn coal, oil, and natural gas, they trap in a lot more heat into the atmosphere, which means there's warmer temperatures, more extreme weather, droughts, habitats destroyed, ice caps melting. It's a really big problem, and solar was a solution for it. So that's meant since the 90s, solar's gone from being basically nothing to quite a significant industry, and it's only growing bigger and bigger and bigger. And that's because of those three reasons I outlined before. And also now, solar is actually one of the cheapest ways to produce electricity. But why do I bring this up in a space talk? So here's a good fact: 3.6 million people employed worldwide in the solar industry. That's they can put 3.6 million people can put food on the table, roof over their head, afford the lifestyle they need to afford to live. And none of those jobs exist if space hadn't pushed so much for solar in the early days, if they hadn't brought down the cost of solar, if they hadn't kept solar panel manufacturers alive and thriving. Now, this isn't the only example of this. So, whenever the space industry has a problem in space, they'll put very smart scientists and engineers and, well, anyone willing to try and tackle their problems. So, one example, scratch resistant lenses. So, NASA wanted to design helmets that wouldn't scratch when their astronauts were out on spacewalks. The technology of stopping the scratch resistant lenses is now on most sunglasses and glasses. None of that happens without space. Camera phones. So, how many of us today will have an iPhone or a Samsung or any phone that has a camera phone on? Now, that started because NASA wanted to have a light miniature camera that could only needed a very little energy to take high quality images in space. That technology has now trickled down into a lot of our phones today. Portable computer. The first ever portable computer was called the Grid Compass, and it was on the shuttle missions that NASA were running. And it was designed just to sort of interact with other equipment on board the shuttle, and also to decide when to release satellites that might have been on the shuttles. Now, how many of us today use laptops? I'm recording this talk on a laptop. That sort of technology came from science, from space. The computer NASA scientists just wanted to be able to interact with the data and manipulate their data a bit better in the 60s. Now, every single desktop sold worldwide needs a mouse to allow it to work. And this isn't just these, so there's landmine removal, foil blankets, water purification systems, home insulation, memory foam, baby formula. This is just a small list of the lots of huge technologies today that affect all of our lives that have been created because scientists and engineers involved in the space industry wanted to tackle a problem that we had in space. And so space exploration is a very worthwhile cause because we should want to see what's happening in the universe, and we should want to know whether we can and if we ever will go to Mars. But if anyone ever asks, why do we pump these millions and millions of dollars and pounds and euros into the space industry, and why do we spend so much money going up there? It's because of things like this. It's worth investing in because the problems they solve end up impacting all of our lives. Yeah. So moving on to the fourth and final part of this talk. So in this part of the talk, I just want to explain how a solar panel works and what's next for the solar panel field in terms of us scientists trying to improve them. So this little diagram can sort of explain how a solar panel works. So at the top, you have an N-type material, and that's a material with too many electrons, and so it becomes negatively charged. On the bottom, you've got a P-type material, which is a material with too few electrons, and so it becomes positively charged. You bring those two materials together, the electrons are going to want to flow from the N-type to the P-type material to address the imbalance in the number of electrons. The problem is the electrons are bonded, and so you need to give them a little jolt of energy to give them enough energy to be free to move. And the movement of the electrons, the flow of electrons. That's what electrical current is. That's what electricity is. So the sunlight is able to provide that jolt of energy that's enough to allow them to be free to move and flow as electricity. Now, in terms of improving them, rather than just have one solar cell, there's an idea to have stacks of solar cells. And so these are called tandem solar panels. And you could then have a solar panel that targets different types of light. So, as you may know, white light is a spectrum of lots of different colors of light. So, you could have a layer that targeted red light and a layer that targeted blue light, for example. So, that means we collect more of the sunlight to produce more electricity. An alternative example is a concentrator solar panel. And what that means is use mirrors to make the light even brighter as it goes into the solar panel, which means more sunlight means more electricity out. Now, alternatively, there's been some people experimenting with making flexible solar panels, and that would mean rather than you having those aeroplane wide wingspans of solar panels, you could just attach them to the outside of your satellite, which would really save weight, which, as I've said at the start, is beneficial for space because it means it's easier to get it up into space and it's a lot cheaper. Now, these technologies, as well as improving solar performance in space, are likely to trickle down into the solar industry down on Earth, and so it's likely to improve the solar panels that you can have on your buildings and you see in fields that are solar farms. And these improvements will also mean that we can push solar further. This is from the film The Martian, and he manages to survive on Mars with solar power as his form of electricity. Now, if we continue to improve our solar panels, then when we do eventually go to Mars and we need a source of electricity, solar could become the clear choice if it's the cheapest and easiest way to get electricity out in Mars. So that's the end of my talk. Just to give you a little summary, I started by telling you how when the space race first started between the United States and the Soviet Union, they quickly realized that solar panels were the clear candidate for powering satellites up in space. And I even went as far as to show, basically prove, that solar panels made nuclear peace between the two countries. Then I moved on and showed you a few examples of how solar has improved our lives and understanding of the universe. So that was GPS, TV satellites, weather forecasts, the International Space Station, and the space telescopes like the Hubble telescope. Then came back and showed that if it wasn't for the space industry, you wouldn't have a solar industry today. And that's not just true of the solar industry. So I gave some examples like portable computers, computer mouses, scratch-resistant lenses, landmine removal. There was all sorts of examples of technologies that have been created to solve problems in space, then coming down to Earth and improving our lives as well. And then finally, I talked a little bit about how the solar panel worked. So the flow of electrons by getting the two different materials and how we were trying to improve them. So if I want you to take anything away from this talk, is this: without the space industry and their need to use solar energy to solve problems, 3.6 million people around the world, including me, that work in the solar industry wouldn't have those jobs that they do today. So thank you so much for listening. I hope you have a great rest of Stemfest. Thank you as well to the organisers for allowing me to talk. And if you do have any questions, I know it's not easy with this being a pre-recorded lecture, but I think if your teacher gets in touch with the event organizer and has any asked for a question from Matthew Smiles, they'll be able to get that question to me, and I'll try and get to you back to you as quickly as possible. So thanks very much.